Hey guys, I actually did just forget one thing. So in the previous videos, we talked about epoxides, right, or just the alcohol reactions in general. But there is one other thing I did not mention that you guys have learned, and it is used in synthesis question a lot, and it can be used for other questions, right? And that's the concept of protecting groups, right? So a protecting group. So what exactly is this? So we use protecting groups a lot in synthesis in order to stop a certain reaction from affecting maybe another part of our molecule, right? And essentially protect it. So how exactly does this all work, right? How exactly does it work? So we use the only protecting group you guys have actually learned works on alcohols, okay? And so what you'll see a lot, and you've already actually seen this at this point, is TMSCl, okay? That's TMSCl, and what exactly does that look like? And actually you should know the structure because they could very easily show the structure itself on an oxygen, and people would get mixed up because they don't know the structure of it. All right. So TMSCl is going to look like this: silicon down to chlorine, two methyls. Sorry, three methyls. Okay. Oh, that's chlorine. All right. And so that protects alcohol. So let's say you have this alcohol, and we use TMSCl on it. All right. TMSCl, and you actually should write it over ET3N. Okay. So what this is going to look like is we can write this two ways. OTMS, right? Just remove the Cl, or the actual structure, which is going to be like this. And so the way I've seen this before is what they'll actually do is they'll ask a SN2, like let's say reactivity question, right? And a lot of people would get mixed up into knowing what this structure is. They won't know what it is. And it's going to be probably the most unreactive one there because it's a protecting group. It's supposed to make our alcohols completely unreactive, right? And they'll get mixed up and they'll get it wrong. Now, the other thing is how we take off a protecting group, and we use TBAF. Okay, TBAF, and you just write it by itself, and so it'll be OTMS, and we get OH. Now, remember, if you're doing a synthesis backwards, it might have to be the other way around. So you could have to put TBAF first, essentially, if you're going backwards. Right? And so, what are the situations that we'll have to protect a alcohol? Well, if you're focusing on synthesis, the one thing, a couple of things we can have together are OHs and lithiums on the same compound. We also can have carbonyls on the same compound as a lithium. We also can have a Br and an Li on the same carbon. Okay, and so you definitely have to watch out for when you have to use a protecting group. Okay, and don't worry, I will go through some synthesis examples where we do use protecting groups because I have a feeling they will give you a synthesis that you have to use a protecting group. And also, those are three scenarios that I gave that we cannot have any of these scenarios. All right, you're not allowed. It'll ruin your synthesis. You'll get points off. But also, if you have, let's say, a compound that have two alcohols on it, and you only want to affect one, that would be a good time to protect. And again, I'll go through examples of how like when to know you should use a protecting group. All right. It's weird at first, but you'll get the hang of it. All right. And so I will see you guys in the next video. Hope this helps.